Welcome to my channel. If you are new to my channel, then do subscribe by pressing the subscribe button. Press the bell icon so you can get notifications for newly uploaded videos. The Mars 2020 mission with its Perseverance rover is part of NASA's Mars exploration program, a long-term effort of robotic exploration of the red planet. The Mars 2020 mission addresses high-priority science goals for Mars exploration, including key astrobiology questions about the potential for life on Mars. The mission takes the next step by not only seeking signs of habitable conditions on Mars in the ancient past, but also searching for signs of past microbial life itself. The Perseverance rover introduces a drill that can collect core samples of the most promising rocks and soils and set them aside in a cache on the surface of Mars. A future mission could potentially return these samples to Earth. That would help scientists study the samples in laboratories with special room-sized equipment that would be too large to take to Mars. The mission also provides opportunities to gather knowledge and demonstrate technologies that address the challenges of future human expeditions to Mars. These include testing a method for producing oxygen from the Martian atmosphere, identifying other resources, such as subsurface water, improving landing techniques, and characterizing weather, dust, and other potential environmental conditions that could affect future astronauts living and working on Mars. The mission is timed for the 30th of July 2020, when Earth and Mars are in good positions relative to each other for landing on Mars. That is, it takes less power to travel to Mars at this time, compared to other times when Earth and Mars are in different positions in their orbits. To keep mission costs and risks as low as possible, the Mars 2020 design is based on NASA's successful Mars Science Laboratory mission architecture, including its Curiosity rover and proven landing system. It will land on Mars on February 18, 2021 at the site of an ancient river delta. It will spend at least one Mars year exploring the landing site region. Perseverance will carry 7 instruments to conduct unprecedented science and test new technology on the red planet. 1. Mastcam-Z, an advanced camera system with panoramic and stereoscopic imaging capability with the ability to zoom. The instrument also will determine mineralogy of the Martian surface and assist with rover operations. 2. SuperCam, an instrument that can provide imaging, chemical composition analysis, and mineralogy at a distance. 3. Planetary instrument for X-ray lithochemistry, PIXL, an X-ray fluorescence spectrometer and high-resolution imager to map the fine-scale elemental composition of Martian surface materials. PIXL will provide capabilities that permit more detailed detection and analysis of chemical elements than ever before. 4. Scanning habitable environments with Raman and luminescence for organics and chemicals, Sherlock, a spectrometer that will provide fine-scale imaging and uses an ultraviolet, UV, laser to map mineralogy and organic compounds. Sherlock will be the first UV Raman spectrometer to fly to the surface of Mars and will provide complementary measurements with other instruments in the payload. Sherlock includes a high-resolution color camera for microscopic imaging of Mars' surface. 5. The Mars Oxygen In Situ Resource Utilization Experiment, MOXIE, a technology demonstration that will produce oxygen from Martian atmospheric carbon dioxide. If successful, MOXIE's technology could be used by future astronauts on Mars to burn rocket fuel for returning to Earth. 6. Mars Environmental Dynamics Analyzer, MEDA, a set of sensors that will provide measurements of temperature, wind speed and direction, pressure, relative humidity, and dust size and shape. 7. The Radar Imager for Mars Subsurface Experiment, RIMFAX, a ground-penetrating radar that will provide centimeter-scale resolution of the geologic structure of the subsurface. Perseverance's body and other major hardware, such as the cruise stage, descent stage, and aeroshell/heat shield, build upon the success of NASA's Curiosity rover and include many heritage components. The car-sized Perseverance Rover has roughly the same dimensions as Curiosity. It's about 10 feet long, 9 feet wide, and 7 feet tall. But at 2,260 pounds, Perseverance is about 278 pounds heavier than Curiosity. Perseverance will also test new technology for future robotic and human missions to the Red Planet. That includes an autopilot for avoiding hazards called terrain relative navigation and a set of sensors for gathering data during the landing. A new autonomous navigation system will allow the rover to drive faster in challenging terrain. As with Curiosity, Perseverance's baseline power system is a multi-mission radioisotope thermoelectric generator, MMRTG, provided by the U.S. Department of Energy. It uses the heat from the natural decay of plutonium-238 to generate electricity. The Solar System is the gravitationally bound system of the Sun and the objects that orbit it, either directly or indirectly. Of the objects that orbit the Sun directly, the largest are the 8 planets, with the remainder being smaller objects, the dwarf planets and small solar system bodies. There are 8 planets in the solar system: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. The 4 smaller inner planets, Mercury, Venus, Earth, and Mars, are terrestrial planets, being primarily composed of rock and metal. The 4 outer planets are giant planets, being substantially more massive than the terrestrials. The 2 largest planets, Jupiter and Saturn, are gas giants, being composed mainly of hydrogen and helium. The 2 outermost planets, Uranus and Neptune, are ice giants, being composed mostly of substances with relatively high melting points compared with hydrogen and helium, called volatiles, such as water, ammonia and methane. All 8 planets have almost circular orbits that lie within a nearly flat disk called the ecliptic. The Solar System also contains smaller objects. The asteroid belt, which lies between the orbits of Mars and Jupiter, mostly contains objects composed, like the terrestrial planets, of rock and metal. For most space objects, we use light years to describe their distance. A light year is the distance light travels in 1 Earth year. 1 light year is about 6 trillion miles. When we use powerful telescopes to look at distant objects in space, we are actually looking back in time. Light travels at a speed of 186,000 miles per second. This seems really fast, but objects in space are so far away that it takes a lot of time for their light to reach us. The farther an object is, the farther in the past we see it. Our Sun is the closest star to us. It is about 93 million miles away. So, the Sun's light takes about 8.3 minutes to reach us. This means that we always see the Sun as it was about 8.3 minutes ago. The next closest star to us is about 4.3 light years away. So, when we see this star today, we're actually seeing it as it was 4.3 years ago. All of the other stars we can see with our eyes are farther, some even thousands of light years away. Mars is the 4th planet from the Sun and the 2nd smallest planet in the Solar System, being only larger than Mercury. In English, Mars carries the name of the Roman god of war and is often referred to as the Red Planet. The latter refers to the effect of the iron oxide prevalent on Mars' surface, which gives it a reddish appearance distinctive among the astronomical bodies visible to the naked eye. Mars is a terrestrial planet with a thin atmosphere, with surface features reminiscent of the impact craters of the Moon and the valleys, deserts and polar ice caps of Earth. Over the past 2 decades, missions flown by NASA's Mars exploration program have shown us that Mars was once very different from the cold, dry planet it is today. Evidence discovered by landed and orbital missions point to wet conditions billions of years ago. These environments lasted long enough to potentially support the development of microbial life. Mars has historically been unfriendly to Earth's attempts to visit it. More missions have been attempted to Mars than to any other place in the Solar System except the Moon, and about half of the attempts have failed. Some of these failures occurred because Mars was the first planet Earth attempted to explore, and the early exploration attempts taught us many lessons that have made subsequent missions more successful. But many failures have occurred relatively recently, proving again and again that space exploration is very, very difficult. But since 1996, Mars exploration has undergone a renaissance, with data from 4 orbiters and 4 landed missions developing a revolutionary new view of Mars as an Earth-like world with a complex geologic history. Thank you for watching the video. If you have any suggestions, please comment in the comment section below.